Hi, I'm Pauline Davies, and today at the Quantum Biology School of Pioneer Science in Paraty, Brazil, I'm with two people who use complementary approaches to the subject of quantum biology in their work. Marucia Chacur, you come at it from a biological perspective, and you're a neuroscientist and a professor at the Institute of Biomedical Sciences at the University of Sao Paulo, where you're working on improving the lives of people suffering from chronic and acute pain without the use of drugs. And we have Marcos Oliveira. Marcos, you're a professor at the University of Campinas, where you teach a class that explores quantum sensor technologies and how they're revolutionizing the life sciences. And your research centers on quantum biology, quantum optics, and the fundamental aspects of quantum information theory. And you're the co-founder of a startup focusing on quantum technology education. So just starting with you, Marcus, can you tell me about your startup, what it is and why you created it?
Yeah, sure. This was started by a collection of colleagues that we back in 2023. We had a gathering and a collection of students that came to ask us to teach people from outside the academic life. So we started actually by doing some courses related to the university, but afterwards we are extending it to the community in general. So this is a different way on teaching quantum mechanics for laypersons. So and we are quite successful into that. But we also this is not the only thing that we do. We improve optimization processes using quantum algorithms for industrial processes in general.
And what's the most challenging aspect of trying to teach quantum mechanics and quantum biology, presumably you're teaching as well, to the layperson?
Well, this is actually exciting because it's something that I never expected. So for example, I worked with quantum computation for 25 years, and at that time we were just talking with specialists in general, and right now I'm talking about quantum computing and quantum information for anybody, like people from the financial market, people from computation, people from teachers, school teachers as well. So this is quite exciting. I have to say that I myself have learned a lot with that.
So it sounds like it's a lot of fun.
It is, sure.
And Marucia, as a neuroscientist, you study pain and how to treat it, especially chronic pain. It's a huge burden in medicine, isn't it?
It is, yeah. I have been working with pain more than 25 years as well. It's very hard to work with this field because it's difficult to. We know that chronic pain is difficult to treat. We don't have a specific medicine that can make the pain disappear.
I read a statistic once that I think said that more than half of visits to doctor's surgeries was to do with things like back pain.
Yeah,
it's really serious.
It is, and hard.
And so, what are you working on in particular?
Yeah, in the field of pain, I work. Parts of my laboratory try to understand how does pain work. Why some people feel less or more pain than others. Oh. And we use a non-pharmacology therapy as photons, like the light that comes from the light. We call Photobiomodulation, which is how the photons, it's absorbed through the skin and somehow gets to the cells and I call decrease pain in some kind of disease. This is why we try to understand using these techniques in different kind of pain.
And what sort of light are you using? Is it red light?
It's not red. It's infrared. because there are difference between red light and infrared, where the red light it's much more superficial, and the infrared goes much more deeper on the tissue. So if you want to treat, for example, a chronic pain or a back pain, which is a little more deep on the tissue, we work with more infrared, which is between 700 and 1,000 millivolts wavelength. And if you want, for example, go to aesthetical and use something for face, for example, I don't do that, but the people use different, like red wavelength, which is more superficial to treat some skincare, something like that.
And it works, does it?
It works, yeah.
Oh, wow.
And it's excellent for them.
That's very useful to know about.
Decrease pain. We don't treat the pain. We don't treat the
right.
But most of the patients that we work with feel much better after the treatment.
And how deep do the infrared rays go? How deep can the injury be?
In some physical experiments, they show that can go to 1 centimeters. 1 and 1.5 centimeters deep in the tissue.
And so what would these be, sort of muscle tears or what?
Actually, 100% of the actions we don't know yet, but we know that this light, after get absorbed onto the skin, that goes to the mitochondria. And then the mitochondria, make her increase the energy, the ATP, and this comes with a lot of good things that's happened on the tissue.
So it seems to be a lot to learn. So, but it is so it's going under the skin for about a centimeter, you said, and so I was thinking about the sort of problems it could be used to treat, bruising. That's why I meant muscle tears.
It can be muscle, can be arthritis, can be any kind of pain that you can use it with no side effect.
No side effects.
No side effects, which much good.
So, is it a fairly common treatment now?
It's much more common in US than in Brazil. A lot of physiotherapists start to use that. Also, a dentist, they also use a lot for ATM.
I don't know. I haven't come across it, but it sounds very good.
Yes. And then it's getting much more used from the...
Can it actually promote the repair of injury as well as taking away the pain?
Yes. They help to neurons, to the glial cells, to release a lot of, for example, cytokines, which is anti-inflammatory cytokines, anti-inflammatory substance that can help indirectly to decrease the pain.
And how do you do your experiments?
We start using animals for experiments. Then we do the surgery in the animals. We apply this. We make them to feel to get neuropathic pain, and then we treat the animals like we do in humans. We just apply the machine against the skin, close to the place that they are. The place that we had the surgery, and then we have different kind of machine that we can measure how much pain they feeling. So we can measure in time, in seconds. For example, if I go with something hot in your thermal, and then I go something hot here, and then the animal or us do the same. We have few seconds we can support, and then after a few seconds we just withdraw.
Right. So you just make them feel a bit uncomfortable.
Yeah, and then you can measure how many seconds they can stand, or how many grams they stand before to remove the member or something. Then you can measure it.
Marcos, this sounds very intriguing, doesn't it?
Yes, it is. Yes, I was just thinking about that. How does that work? Because it's, light, anything that involves light for sure, at some certain level, it involves absorption and emission of light from the tissues. But I don't know really. Like this is why this area is quite interesting, because there are knowledge that you can achieve from like from physics, and also there are some knowledge from the physiology and biology that like we need to interact. This is a really a very large, a new area that needs the involvement of many kind of expertise.
So maybe it's a new collaboration between the two of you.
It's a field that is growing up a lot. I think this school is helping us to interact, like he told us, to physics, chemistry, and biology. And then if you think all together, I think we can grow up with the research much faster than work alone. Yeah.
Where does the idea come from? I mean, you mentioned I think it's been used for about 20 years, but has it got a long history?
Yes, there is an history that comes from the Nobel Prize in 1909. A physics person, I think his name is Finsen, and he's from Denmark, and he's the one who got the Nobel Prize using the light from the sun. I don't know how, but they put some kind of the sunlight in a machine, and then applied against the human, and then he saw that the patients was feeling much better, and then that time was a huge discovery. But then after a few years, they just disappeared everything because, and then in the 80th century, I think with the increase of technology, these ideas come back. Like, then they can make new machines. There you can put the laser inside, and then you can regulate it, how much energy you can apply, or you can measure how much wavelength it's really apply against the skin. So we could work. We can work with different called dosimetry. Like you can really know how much energy is coming, or you can choose what is the better way to treat this.
And I presume it is completely harmless, is it? It's not going to do any damage at all?
No, because we don't use a very high potency, so we do not get warm.
Okay, so you
cannot get any damage on the skin.
Make sure you've got, so if you do it at home, you've got the right equipment. Okay, and Marcos, so one of your interests is quantum optics. Does your work intersect at all with what Marucia is doing?
Yes, I started a long time ago with working on quantum optics, and I do work with a lot of things, physical things, because the mechanism is similar. The systems are different, but the mechanism is always related to absorption, emission of photons. Which means that I do love to describe the light as a quantum system. And so whenever there is light absorption and excitation, like in this kind of system, so quite possibly there is a quantum phenomena going on behind. But in quantum biology in general, which is a new area, and we are still defining it, there is still what is to be considered quantum in the area. So usually there are processes that involve spins, degrees of freedom as well, which is something very native, a quantum thing. And efficiently, when we have a process that involves absorption and emission of light, and it also involves some degrees of freedom, spin degrees of freedom, then this is quantum in the actual sense.
So this is what you're talking about, some fundamental quantum processes.
Yes.
Do you think that there could be these fundamental quantum processes going on in the brain, or is that too much of an extreme environment?
No, certainly. I mean, as a scientist, we cannot, just forget about those questions. We have to be careful, of course, because there are many pseudoscience behind this kind of discussion. But what we want to know is that if it is necessary to describe it as a quantum, a quantum process or not. Is there any phenomena that we really need a quantum mechanical description to understand that phenomenon? So this is what we are going after. So there are many phenomena nowadays that can only be described when you use quantum models. So it's not just only happening in the nature itself or with phenomena that we use in devices, but also with animals and birds and all insects that we have. And for example, the photosynthesis, quite possibly there's a quantum phenomena behind of that.
That's right. And at this school, we've heard about the magnetism in the bird's eyes, the avian magnetic compass.
Yeah.
But I want to stick to trying to drag it back to human biology for a change.
Sure.
Consciousness.
Okay.
Things going on in the brain. Does your research, can it give any indications of, I mean, does quantum processes play any role in consciousness that you know of at the moment?
Yes, sure. We have to be careful again here when talking about consciousness. We are not talking about, some non-physical stuff. So we are talking about the sensation, how the brain and the body have a perception of the external environment.
Yeah.
So this is consciousness in the way that we speak. So for example, when there is the action of anesthetics in the brain, the anesthetic,
okay.
Yes, it shut down the brain perception to external impulses, but it keeps the body alive. So this is a kind of this is the kind of consciousness that we are talking about. So the anesthetic shuts down this perception of the brain. So the way that this propagates the information when you apply some anesthetic to a person or to an animal or whatever with brains, it's quite similar to what happens when you have a propagation of signals propagating in a quantum way. So my question is it possible that there is some coherence, we call it quantum coherence, happening at some level at the brain, that we can only understand this propagation of signals when you use this quantum description or not?
Is that something you can actually investigate, or is it still just sounds really tricky at the moment?
It is tricky because there are some people, very famous people, that proposed some models a long time ago, and people after other people have proposed different models and also destroyed completely that initial theory, because this is a very complex question. We don't know what consciousness is really in the actual sense. So but when we limit ourselves to specific phenomena, to a specific class, and we physicists, we like to do this, simplify things, and then we can understand what can happen, what cannot. So whenever we have a very complicated theory, but if this complicated theory describes in the same way that a very simple theory describes as well, I don't need this complicated theory. So we can use the classical, phenomena as well. But to rule out this quantum description, I have to be sure, I have to be certain. So why not to ask those questions? Are there many quantum phenomena happening in the brain? We don't know really.
I've always heard that it would be hard to maintain in the brain because of the decoherence of the quantum processes. But how else do you explain consciousness? Well, it's an open question, isn't it?
Sure.
But Marucia, does this sort of thing interest you as well?
Yeah, if I can jump in his answer, I believe something happened over there. in the brain, but as you told, it's very hard to explain how the conscience is. We don't know either which part of the brain is involved in this issue, but for sure something is happening much more than classic books is, right? Now we know that how we teach, we know that there are many synapses that communicate with each other neurons, and then they can propagate the impulse and then can do a lot of things in the brain. But I think the most hard and difficult way, it's a very difficult question to answer that. It's very difficult to answer this question, because sometimes, like we were talking here, it's the brain, it's a very complicated place. It's a warm place, it's a wet place, and then sometimes when I see quantum biology, is much more in a very controlled place. It's something that should work, if I'm not wrong, in more very specific way, very cold place. And at the same time, I believe that, yes, something happened more than just a synapse in the brain, but sometimes I also think it's hard to prove or to do some experimental experiment to prove that some quantum... We were talking about this a little before. We were talking about vibration no, in the brain. Maybe you can explain much more than me, since he's physics. We are talking that maybe much more than synapses happen there, like one to the other one.
Yes,
so I hadn't thought about vibrations in the brain.
So again, I just, we have to be careful when we talk about this. Well, we're talking about here, consciousness is the propagation of signals through the brain. So if you have a network of, like a synapses, this is exactly what happens, for example, when you have an optical links. When you have an optical network and you propagate a signal to communicate with many people, like we are doing right now. So this is exactly quite possibly what happens at the brain level. So when there is information propagating from one point to the other. But this propagation could be classical in a way, to be diffusive, but could also be quantum in a way. If there is some quantum coherence, then it would propagate as waves through those links, through those synapses. So this is a question.
Yeah, it's fascinating to speculate about, isn't it? I know that it is just speculation. But I've actually got a question from Marucia. So she's using your infrared light. I was just thinking, can it actually penetrate the skull? Can it cure headaches?
There are a few, maybe a few studies that growing up, they're using this kind of machine, transcranial, through the skin, transcranial in the brain. This field is growing up in the psychologists, where they are trying to help the people with depression.
Really?
Yeah. So we know that when this light it's applying against the skull, some way they can be absorbed through the bone, because I have a bone here, and in the brain, and help them to release, for example, dopamine, serotonin, which are neurotransmitters that is, we know that is helping to happiness. And then it's a lot of people, a few psychiatric people are using this kind of techniques to help those people, not with headache, but with depression.
Oh, so it really, in a sense, it's manipulating what's going on in the brain, isn't it?
This is why we believe that something,
thoughts even.
Something, the lights for sure can act in the cells, doing something.
And Marcos, would you say that this is quantum, a quantum process, or not?
Well, it is quantum in the sense that some light is absorbed by the brain tissue. But if there is a quantum process in really which is necessary in the sense, for example, for sure we don't have entanglement happening here, which is a very characteristic feature of quantum beings. So I think that that it could be possible, you know.
It would be exciting if that could be true, wouldn't it? As long as if people manipulated the thoughts in a way that's going to help people.
Yeah.
So, you know, that I suppose you're up against some ethical considerations there.
Sure.
Yeah. So I wanted you to describe some of the sensing technologies that are happening now that can really impact human health.
Yeah, sure. So, for example, we can use some bio-inspired systems. So the animals and the nature itself uses many ways, you know, to go after, you know, what is important and it's more relevant for life in general. So we try to understand how those things happen in the nature in general and try to adapt it to the lab. So I'm not an experimentalist, but you know there are many good people that actually they try to copy those processes in a way that we have more efficient devices. So there are many devices that are not specifically based on biological beings, but they are, you know, somehow they are much better than you can do with the classical sensing. So whenever you reach a certain limits, you can actually use those sensors for detecting very, very small magnetic field, temperature, and also currents in general. So this is important for any kind of application in the life sciences. So, for example, for scanning the brain, as we were talking about, and or even for for sensing what they are doing when they are reducing the pain by applying certain wavelengths of light. So this is so quantum sensing is good for that. We can push the boundary for what we can sense, we can detect.
Yeah, it seems to have been developing very quickly over the last few
years.
It
is. I have to say this is one of the most in the quantum technology. All the quantum technology things which are related to quantum computing, quantum information and communication, and quantum sensing. Quantum sensing is the one that really is developing quite fastly because there are many applications out there.
Mm. Yeah. And as you're mentioning, it's fairly recent and it's improving quickly. Looking ahead 20 to 50 years from now, can you imagine what sort of quantum sensing might be available then, and how it might impact human health? And this is actually a question for both of you, I think.
Yeah.
Marucia.
I think like he explained, the technology it's growing up. The device is much better. fMRI. Yeah, fMRI. It's getting much better, for example, for image. So if you can diagnostic something early, it's much helpful for the human being. So I think with this technology, we're going to try to help it to get the diagnosis for some disease, for example, much faster than we have today, or when the disease is a little small things. That's something that you cannot see today with the device, but with the future device, I think we can find that possible disease much early to try to treat the patient much earlier than
faster. And
yes, and certainly. So, for example, something that I'm going to talk about at the school is called NV centers in diamond. So there are those nanodiamonds. They have the sensibility to detect very small magnetic field variations. So this is quite important because it's similar to when you have a very old TV set and when you compare it to a new TV set with a very bright image, so those guys, if they attach it to the brain, they could, give an image which is way more efficient in related to the old one. So you could actually see small, very tiny variations and see how many other phenomena, and describe how this could, not just the image, but how this image changes with time, and how this, is related to some specific disease. So I think this is really important.
So finally, would you both agree that quantum technology is really transforming medicine?
Yeah, for sure.
Yep.
Yeah, sure. This is something that we haven't talked, not even talked about that. How can you optimize, for example, many processes? So, like for example, there are people discussing new methods to new algorithms to describe equations which are very hard to simulate. And so those people are using this to describe, for example, the flow of blood in the human tissues, for example. So this is something very interesting, like if you have new algorithms, so there's nothing quantum going on there in the system, but you can use quantum computing to accelerate the computation and and also how you calculate those phenomena which are very hard to simulate and calculate in general. So this is very important for the health.
And I can see you're bursting to say something, Marucia.
Yeah, I was trying to say that in the summary, what I think it's this, with this technology, we can get the answer much faster. Like, because the computer and the normal computer get something that they get years or months, if I'm not wrong. With the quantum computer, they can get the answer within a few seconds or days or minutes. So this is much helpful.
So really, this is a field that is requiring the skills of many different types of people.
Mm-hmm.
People like you, Marucia, and Marcos, and quantum physicists, computation specialists, biologists, a whole range of people.
Yes.
Bring everyone in.
Yeah, I think we have space
Sure.
for everyone.
Yes.
Thank you so much.
Thank you.
Thank you.